Welcome to our video tutorial involving angles with circles. We are going to work through the problem on the screen. Perhaps you want to pause first and see if you can work it out before we discuss together. Now, as we do this problem, please stay organized. So the first thing that we're going to look at is we have a full circle. And we have a number of the degree measures specified here. And we need to figure out what the missing degree is for arc GF down below. Since the whole circle has to add up to 360, we can take 360 and subtract away the pieces we know, which would be the 87, the 51, the 24, the 68, and the 15. And when we take 360 and subtract all those numbers, we get 115 degrees down here for arc GF. Now, once we have done that, we're going to look one at a time at what we want to solve for. So first we're going to look at CGE. CGE is this angle that is being highlighted in red on the screen. If we want to solve for that angle, notice that its vertex is on the circle. When the vertex is on the circle, we take the arc that it subtends or that it eats and we divide it by 2. On a test or a quiz, please show the work. Now you can take 68 and 15. We're going to add those together, and the full arc there is 83 degrees. So we will take the 83 and divide it by 2. Yes, it could be a decimal, and I get 41.5 degrees for the measure of CGE. Next, let's go to AHG. So find angle AHG in the picture. AHG goes like this. Now when the vertex is inside of the circle, I would encourage you to extend those two lines as I'm doing right here, and to just really emphasize the two angles we care about. AHG is right here, so we care about these two arcs that I'm shading in magenta. Remember, when the angle has its vertex on the circle, we take the two arcs, add them together, and divide by 2. Here the two arcs are 87 degrees and 68 degrees. Now we can just type that on our calculator. 87 plus 68, we get 155. Divide it by 2, and that turns out to be 77.5 degrees. That would be a sufficient amount of work to show on a test or any other assignment regarding the measure of angle AHG. Now let's continue working this problem through and try to figure out the measure of angle AEG. So AEG is the angle that I've just highlighted in green. When we look at that and when we remember from class, you take the difference of the two arcs. The larger arc, which I'm scribbling right here in green, that's an 87, minus the smaller arc, also scribbling in green, that would be the 15, divided by 2. Get the numerator first. 87 minus 15 is 72. Divide that by 2, and we get 36 degrees for the measure of angle AEG. Next, we will go and look at the measure of angle ADB. So ADB is being highlighted in red on the screen currently. Its vertex is on the circle. So we'll take the angle that's being subtended or eaten by that angle. The arc is 51 there. We take that arc, divide it by 2, and that will get us the measure of angle ADB. 51 divided by 2 is 25.5 degrees. Okay, let us continue to angle CID. Now CID is going to be this one that I'm highlighting in blue right here. I would then continue it in each of those directions because the vertex is inside of the circle. Look at the angle you care about, which is CID, this angle right here. So the arcs being subtended would be the 68 degree arc. That's going to be one of the two that we add up and divide by 2. And the other one is going to be 51 and 87 combined. So you can just go ahead and add up the 51 and 87. Get 138. And now we'll take 68 plus 138. Hit enter on that, or put parentheses around the numerator. divide it by 2, and we'll get 103 degrees for the measure of angle CID. Sometimes I will have that drawn to scale, other times it won't be drawn to scale. So trust your numbers and hopefully you're calculating it correctly. Now the final thing that we have in this problem is to calculate the length of arc AD given that the radius of the circle is 12. So when we want the length, remember it's going to be the fraction of the circle, so some number of degrees out of a full 360, times the full circumference, which is 2 pi r. In this case, when we're looking at the length of arc AD, the radius is 12, the number of degrees is going to be the 51 plus the 24 plus the 68. So that's going to be 143. And then we'll just simply type that in our calculator. Please use your pi button. Don't use 3.14. And when we calculate that all out, I'm getting 29.95. Put a unit on it, 29.95. The label would be centimeters based on our radius, so 29.95 centimeters. If we ask you to calculate a length of an arc, first figure out the number of degrees of the corresponding arc, and then take that out of 360 times the full circumference, 2 pi r. It's basically finding the length of a fraction of the circle. This is the approach that we take when we're solving for angle measures or lengths involving angles in a circle. Please remember, if the vertex is on the circle, the angle is the arc divided by 2. If the vertex is inside of the circle, the angle is the sum of the two arcs divided by 2. And if the angle has its vertex outside of the circle, the angle is the difference of the two arcs divided by 2.